Hey, I'm Greg Gillismith, and I wanted to take a minute this morning and talk about what does it take to build a container cabin or container home by yourself. And the first thought that came to mind is you have to be crazy. And then I realized that's not very helpful because there's a lot of crazy people who would never be able to do this. So I really tried to identify what are the traits, what are the skills, abilities, what is it that it takes to do something like this. And the first thing that really came to mind is that you have to have the personality, kind of like an Olympic athlete or a top salesperson or or a Navy SEAL or something like that. And those are the types of people that will put in the work every single day, no matter what the circumstances are. And really, that's what separates the performers from the rest of the world and in anything. And so this is, I never knew, I knew I would never be an Olympic athlete because I just am not athletic. But possibly if I trained every single day and really put the work in, I could achieve some skills there. But my natural abilities are in problem solving, engineering, construction, hands-on building and making. So that's where I focused. The first thing then that came to mind after that is to be completely fearless. And fear has to wake you up instead of shut you down, and criticism has to power you. I think I have a clip, and I'm going to try to find it. I was standing at the end of the street when the big trailer is pulling up to drop off this ugly yellow container, and I realized, oh my gosh, I'm committed now. Here's my container. I've got to make this work. Here's the container. Wow, crazy. A little banged up, but it looks all right. And, when I took the angle grinder to the center of the container to cut it in half, I realized, wow, there is definitely no going back. Once I cut this container in half, it's not like I'm going to sell two half container pieces off to somebody. Had to make it work. So that is one of the things that as you get to every obstacle, and I'll cover that in a minute, is that you get to every obstacle. There's fear, there's the unknown. I didn't know how I was going to solve certain details, even major things, before I got started. And so you just have to realize you have to come up with a solution. So, what are some of the other traits? Well, one of them is that you basically have to be so focused and relentless. And I don't mean like these traits that I'm talking about to be able to do this. I don't mean that these are things that you like or would like about yourself. These have to be traits that people have told you before that you possess. And I've had several bosses describe me as relentless. And at the time, I don't know if that was a good thing or a bad thing, but it can be focused into both. And but by relentless, I mean that no matter the weather, no matter, so I was out here building in blizzards, in rainstorms, in windstorms. And the same thing that you would say about a Navy SEAL or an athlete. It didn't matter if it was raining or snowing that day, they still trained. And the same thing here is that no matter what that weather was, had to keep going. So, I was trying to think of the top 10 reasons why it's great to do construction when it's 22 degrees outside. And the first one I came up with is it's a dry snow. And that means, when I set my tools down and the snow blows in the big opening up here because I don't have the wall done, and it blows in on my tools, then I could just brush it off. And then I thought of another reason was you can use a leaf blower to blow all of the snow out of the attic. But then I realized that's just a corollary of good thing number one, because the snow is still dry, that I can use a leaf blower. Let's see. So still thinking of number two good reason. Oh, it doesn't stick to the lumber that is sitting out here. So, but I guess that's still kind of like item number one. It's pretty. I worked on this while I had COVID. I did this while my stomach wasn't feeling well. And so, going back to like the first days when I bought this property, and I went down to the county and had a meeting with them, and I said, I'm interested in building container cabins up here. Here's the very first thing they said: "That's been tried here before, and no one's ever done it." And that is how I got started. So the very first words working with the county is that they doubted that I could ever do it. Never been done, never will be done. They don't want new things. I'm building this in a county that is known statistically as lowest education per capita, lowest income per capita of the state of California. And I'm in California, which means regulations and logistics up the wahoo. And so I had to embrace all that stuff. Now, think about codes and building codes and how you do things. One of the other, obstacles along the way was that this isn't built the same way that a house is, right? You don't have studs and stud bays and those kind of things. You also have a structure that you're working with and around and through, which is unlike when you're doing traditional framing. So from the very beginning, I had opposition from everybody, and then there's opposition from neighbors. That they don't like the unknown. They don't want something like this being built in their neighborhood. They were afraid it was going to look like a Long Beach shipyard. Everything. And they would have meetings in the community, and they would talk about what I'm going to do. I swear I needed to go to those meetings to find out what I was supposed to do, because apparently they knew more about it than I did. But they would talk and they would gossip, and they didn't even know what they were opposing. They didn't even know what it was going to end up looking like. So, gosh, let's see. And then, like I said, the weather. Man, so I delivered these up to this property in early and mid-December, which was the record snowfall December on record for California. And right where I'm sitting, right, the height of these railings right here is about 4 feet high, 5 feet high, and that's the level that the snow was when I was trying to put these on the footings. I was digging the footings during the Windy Forest fire, so I was actually still here during evacuation time, and I was digging these footings. So during fire and snow and wind and rain, didn't matter. I had to still be here making progress. I didn't have a snowblower because mine burned up in the castle fire. And so, sure enough, one went for sale on Facebook just around the corner. This little tiny thing, non-self-propelled, just a little tiny, unit, and I'm trying to attack 4 or 5 foot tall snowbanks. So I had to use a shovel and pull the snow down onto the ground, and then blow that off, so that I could clear just enough area that I could bring the container in. Then the next thing was, I got it all clear, and there was ample room around here. I called the crane company and I said, "Hey, I want to have these things lifted." And you got to understand, the driveway literally from my hand over here is like 10 feet away. And all this area was cleared out, ready to go. There's a power line right overhead. That's about 20 feet up, but it's not. I'm not moving it that far. I'm moving the container literally 20 feet. Crane guy came up here, looked around, says, "I can't touch this until June when there's no snow around." Well, what were my options? I mean, if the crane won't move the container onto the footings, the entire progress was going to stop. And I could take that as a sign to say, you got to put this on hold. And I had the containers up here. The interiors were already, nearly finished, but they were sitting over here in the snow. They had snow piled 3 feet tall on top of the containers. Well, I had to figure out a new solution. So if I couldn't lift them in, they weigh about 4,000 pounds. Maybe I could roll them. So within a day, I designed a bracket, and I found some wheel hubs on for sale on Amazon. So these are bearing wheel mounts. So these are like the non-driven side for a car, and I think it came off of an Isuzu or something like that. And I found a junkyard that had Isuzu wheels and tires already mounted. And so I designed this bracket, and the bracket had to be just long enough, I think it was like 7.5 inches, that it would fit into the C channel on the sides of the container, and it would fit right into that, and then extend out enough. Then the wheel hub would mount onto that thing, and then you put the tire on that, and it would stick out just enough that the tire wouldn't rub on the side of the container. Because remember, there's 2 inches of insulation and siding on the outside of this thing. So, and the doors and windows and some of that kind of framing and everything. So I designed it up, sketched it, put it into Fusion so I could do a finite element analysis to see if I was even close. I had some angle iron left over from the window penetrations that I used for framing those out. So it was like 1.5 by 1.5 by 1/8 inch steel. And so I designed it in Fusion, made some approximations about the load that I think I assumed something like worst case was 2,000 pounds acting on the end of this thing. So talk about skill sets that you've got to have. You know, at a moment's notice, I had to be able to engineer, analyze, and then run back to LA, cut these things up, weld them, order the wheel hubs from Amazon, get those in time, machine these things, put them all together. I was out at the junkyard getting the wheels and tires off of the Isuzu out in pouring rain, and so got them, put them all together, welded them up, and then drove back up here. Drilled holes in the C channels, mounted these things on the containers. So I had to devise another way to move these containers. And here it is. So these are the wheel hubs available for $35 each. It's amazing. It's a machined bearing assembly. It has the lug bolts sticking out of it, the studs, and completely machined and ready to go for $35 a piece. They go on an Nissan Sentra, Nissan Rogue. So then I found a Rogue at the wrecking yard and got 4 tires and wheels. So that cost $400 for the tires and wheels. These at $35 a piece. So that's $70 for the pair, then $140 for those. The steel I had left over from the container, so basically for something on the order of $550 or so, and some of the hardware, whatever, to bolt this together, I now have a way of moving all of the containers, so I probably won't need to hire a crane for any of the other ones. And no, the welding is not pretty, but it should do the trick, because these mount in the C channels. So this will mount down in a C channel like this and give enough offset for the tire and the overhang of the container that this will bolt right into the C channel. And by doing that, the top part is going to fit in the top part of the C channel, and these are only going to carry tension. So if you can picture it sitting like this, and there'll be an upward force on the tires and then a downward force of the container C channel right here. These will just be in tension. So it's only 2 bolts to undo for each one of these things. And then I'll line drill these at the container so that with just minimal bolting and unbolting, these can be attached. The idea is to put them fairly close to center line on the container. And then with a winch and a truck, and a lot of pry bars and ratchet straps and, oh my gosh, everything else, was able to move the containers from the other side of the property down the driveway and then pull it around all these trees and get them onto location here by myself. I had no one else around, and I think it took a full 6-hour day. And I say full 6-hour day because remember, this is midwinter, so it was getting dark early. I would get up here as early as I could. I'm in snow pants and snow boots, and it's blizzard, and I'm dragging these things down, and they're banging into the truck, and there's dents in the container over here from where they've banged into different things, and got them onto the footings. And then right when I got it onto the footings, this container over here slipped off the footings at the very last minute. And so catching it, on the jack, and then, oh, I broke the jack. And so, oh my gosh, yeah, just one obstacle after another. And you just can't use any of those things as an excuse to stop. You just have to realize, okay, the way you move containers is with a crane. And the local two crane companies are saying, no way. Well, you can't stop and quit. You can't go back. You got to figure out a new way. So let's see. So we got the county, we got the crane, we got the weather, we've got not feeling well and throwing up over here in the forest. Whatever it is, you got to just keep on going. All right. So one of the other big skill sets that you need to have is the ability to problem solve about everything. You need to have some skills and experience with everything in construction. So from the ground up, just digging, concrete work, framing, cutting steel with an angle grinder, um, electrical, plumbing. And so one of the design requirements that I had in putting this together was that it would not require any skills outside of basic carpentry. And so what that means is no welding, no drywall, no tile setting, no granite work, and those kind of things. So all of my material and design choices had to be based on carpentry. So like my backsplash is corrugated galvanized roofing. My shower is standing seam metal roofing. Um, the floor is clicked together interlocking vinyl planking. All the wall covering is some kind of wood paneling. So all of that is basic carpentry with carpentry tools. So, but you have to be able to problem solve on the fly. Think about where I am here. I'm in the forest. There's not a lot of resources here. And so, there's also no store within an hour. And so, you have to sometimes problem solve with what you have on hand. And, or it goes on the list and you figure out what to do it later. So, but problem solving, doing calculations and things just on the fly, I would often have to step aside and do trigonometry, do stress analysis, figure out if something was going to be strong enough. All that kind of thing had to be done, on the fly. It's nice having a little more friction at the top. So try to back down in between. So that's actually good. The strap is on my hands. Here in a second. Okay, now it's on the top. So, just another thing that has to do with like focus and the difference between saying, "Oh, I've dreamed of making a container home," or "I've thought about that," or "I like doing that." Let me ask you this: I'm sure you've said the same things about things your wife has seen on Pinterest and on Etsy. Have you really done them? If you're not able to have the focus and attention and tools and dedication to do some crafty project like that, you shouldn't take on a project like this. If you stop halfway on this, it's not weather tight and it's ruined. And so I've got about, I'd say $35,000 in materials into this so far. That includes everything from the finish work, appliances, kitchen cabinets, the framing, the container itself, all that kind of thing. So all that would just go in the trash if you just stop halfway. So lots of problem solving. You also need to hire in some skills. So like I said, this is in California. I'm doing this with full permits and inspections. So right from the beginning, I had to hire a structural engineer. I knew that because this is something that isn't really recognized. We all know it's a structure. It gets used for holding, I forget, it used to be posted right up here on the wall of the door, and it would say how many pounds, and it's like 60,000 pounds that these are rated for in their original condition. right? So we had to understand what happens when you cut holes in the side. Now, one of the things I did was I did not cut entire walls out of these things. They're not meant to do that. Once you cut the entire wall out, it's no longer a nice I-beam box structure. So I did finite element analysis on my own to figure out what the holes would do when I put them close together, what happens, how big I could make them. Then I hired the structural engineer. He confirmed my calculations, and then he stamps all the detailed drawings on that. So when that goes to the county, they see that there's an engineer who's taking responsibility for that structure. And that is one of the major milestones that you have to do, is have that engineering stamp on your drawings, or you've got nothing. Right, so structural engineer. Also, being up here, and chances are if you're building something like this, you're going to have to hire a soils engineer. And the soils engineer has to come out here, and they have to bore holes and do percolation tests and all that. And then they have to design the septic system. And then, of course, I hired in the folks to put in the septic. So I picked up the tanks myself. Oh, speaking of that, that was one of the other ones, is right from the beginning, when I got the container, cut it in half, 20-foot container, I started looking around how I was going to transport them. It's going to be really expensive. It was cheaper for me to buy my own brand new 20-foot trailer, and then I actually had to change trucks to something that would handle something with more towing capacity. And so every one of those obstacles, how am I going to get the containers here? And so now I have a trailer. Now I have an F-250 that'll haul the things, and I pulled them up here myself in a snowstorm. Okay, so it's like, how is this all going to behave with chains and four-wheel drive and all that, with 4,000 pounds sitting on top of a 3,000 pound trailer, etc., etc. I got it here. So, all right, so we got soils engineer, we've got structural engineer. Yeah, California. Fire sprinkler engineer. So I looked into, what is it, NFPA 13, R, whatever it was, and looked at what are the requirements for fire sprinklers. Turns out they're not to put out the fire. They are to provide enough time for safe egress in case there's a fire. In case you haven't noticed, the container is 8 feet wide, 20 feet long. I purposefully put a large open window at the far end of the bedroom. So this is the bedroom here. This window does not open because I wanted a nice picture window with no screen and all that kind of stuff. But at the other end of the bedroom, the far end, the remote end, big openable window. Just in case there were a fire in this container, you can go out that window. It's 2 feet from the bed, okay? So if there were a fire, 2 feet is the furthest you have to go. If you're in this container, let's see, there's a kitchen window, there's a dining window, there's a front door. All of those are within about 10 feet. I mean, even if you're in the toilet, you're 10 feet from the front door. And then if you're up in the attic, there's 2 big windows that open up, one actually over the this entry cover. So, okay, so the fire sprinklers are going to do what? Provide you enough time to get out. You're under 10 feet from a door or window. It's a metal box with concrete siding. This is all concrete on the outside of this thing. So I wrote on my plans, due to the construction size, egressable window locations, and the materials of construction and everything, we see no need to provide fire sprinklers because there is no need to increase time for safe egress. They signed my drawings. I'm like, whoop-de-doo, look at that, you know? Then they realized what they signed, and they put my entire permit package on hold. In the middle of the pandemic, trying to find a fire sprinkler engineer who would engineer something like this. Now granted, because these are 2 8-foot by 20-foot containers that have a door in between and then an attic, you only need 2 fire sprinklers per space. So 2 in the attic, 2 in this container, 2 in that container, and then you have to do the calculations based on the 2 most remote heads. Well, remote also being that they would be the ones with the lowest pressure. Well, obviously those would be the attic because they are the highest in elevation and the furthest away. So it was pretty easy to understand which heads needed to be calculated. I've got 105 psi inlet pressure. Well, from my experience in working on designing water systems for villages in Honduras, it was pretty easy. I pulled out the software. I ran my analysis for my pipe that goes from the street to the container, then the loss of head pressure going up to the attic, made some wild assumptions about things to make sure I was covered. And I said, okay, fine. Here's the calculations. It's pretty simple. These two heads at this elevation with this pipe, all these fittings, they wouldn't accept it. I had to go all the way up to the California, what is it? It's the Grand Fire Marshal of the state of California and say, look, it appears that your assembly bill, I think it was like 433 or something like that, allows owner builder to do their own fire sprinkler design and installation. And they said, oh, no, we never intended that to be the design. It was only to do your own installation for owner builder. I'm like, but here's the calculations. It's really simple. Nope. So I think it was $2,500 later, hired an engineer. They calculated the two sprinklers in the attic, and they said it was fine. And I got my little stamp, and they signed it off within a week. Unbelievable. So I plumbed it all into Uponor PEX and put all the fire sprinkler stuff in there, all done. But again, hiring out all the right people. So structural engineer, soils engineer, fire sprinkler engineer. I think those are kind of the required ones that you're going to have. Oh yeah, Title 24, energy calculations. That gets interesting too. It doesn't like mimic the same models for analysis, right? You don't have studs with stud bays. So I had to really go through the description of how this whole thing works. So normally you've got, say studs that are 16 inches apart. So if you think about this, you've got 1.5 inches of wood and then 15 inches of insulation. And so you've got this interesting thing where 10% of your wall is a thermal bridge, and then 90% of your wall is insulation. And you have, so that's what they're used to analyzing. I don't have that. I've got a metal skin with 1 inch of insulation on the inside and 2 inches of insulation on the outside. No thermal bridging except for screws to hold this whole assembly together. So I had to find an analyst and an engineer who was willing to come up with creative ways of analyzing this and modify the models. And you've got to ask those questions right from the beginning. You don't want to hire your normal structural engineer or Title 24 engineer who's used to doing this the same way every time. You also want to hire engineers who are from the area. There's another YouTube channel out there where the guy's building a container home out in Joshua Tree. And I think if I remember right, it's been a year or two since I watched this. He hired a structural engineer out of the East Coast. Okay, folks, we have earthquakes in California. You've got to understand how seismic loading is different. So you've got uplift loads from winds, which are different in Florida, East Coast, Joshua Tree. Those are all going to be different. So that's wind loading. Then you have seismic loading. You've got your dead loads, your live loads. And then it's a container, when you've got holes punched in it. So it's metal. It's a whole different world. One of my design requirements is I wanted this to be installed onto 9 discrete piers. Or footings. I didn't want to do an entire wall because that required building forms and doing all the rebar in all those things and doing a big pour. And I'm in a forest and I didn't want to disturb all the roots. So by doing individual augured holes, I was able to isolate those loads into to 9 locations. We put all those holes in under an hour, I think it was. We got a tractor, the auger, popped in the 9 holes. I followed with a shovel to remove some of the dirt. He went back in and augured some of that stuff out, and we got our 18-inch diameter holes. So, but you've got to have an engineer who's used to doing these things for this area. The big thing I have up here, snow loads. I think the spec on this area is 200 pounds per square foot on the roof. So you have to have someone who understands. Then when it's a metal roof, at a certain angle, you get a derating factor for your snow because it'll slide off. So someone who is used to all that kind of thing, if they just assume 200 pounds per square foot, you're going to be way over engineered for what you've really got up here. So it's important to hire in all the right people. Well, I hope this has been helpful to just have some idea of what I found that is required to be able to build one of these things by yourself. Now, I think a lot more people would be able to build these on their own if they hired more of those skills in, right? But you still have to have enough knowledge about how to guide those people. And like I said, picking the right team that has the right experience, the right open mindedness to new ideas. When you come up with the idea of where you're going to route your electrical and your plumbing, it's an awkward situation if you're a homeowner or a designer and you say, now, Mr. Plumber or electrician, hey, I want you to put the Romex here. I want you to do it this certain way. They don't necessarily like to be told what to do and how to do it. Now, because I'm the electrician and the plumber, I had this conversation with myself and I was just like, hey, what's the safest way to do this? And I have to read the code. And the code says things like, route the wiring through the center of the stud. I don't have studs. But why do they say that? Well, it's so that it is the safest place to put a wire. And I have to think to myself, what's the safest place to put a wire where I would never get hit by a screw? I had to think through that, and then I had to direct the electrician, me, and said, put it here. And but that might get awkward if you're working with a team and you're saying, I think the safest place to put this. And they're like, nope, that's not the way we've done it. We always put it here. And what I see on YouTube a lot is that they end up putting another whole frame structure inside this tiny little box in order to create studs so that they can build it the same way. Well, what's the point of building a container home if you're just going to build another stick frame house inside of it or outside of it? No. So if you are going to hire more of those skills away, you've got to have people that are open-minded. So, well, I hope this has been helpful. If you do have other further questions, feel free to reach out to me in the comments, and I'll try to get back to those. And if there's enough of them, maybe I'll put together another video or something like that. So, good luck, and I hope to see your video out there.